My name is Zhichen. I'm a PhD student in Shanghai Jiao Tong University. It is a pleasure for me to introduce our work in SigDial 2022. The title of our paper is UniDU towards a unified generative dialogue understanding framework. As we know, there are 5 typical dialogue understanding tasks, including intent detection, slot filling, dialogue completion, and dialogue state tracking, and dialogue summary. The 5 different tasks aims to interpret a dialogue from 5 different perspectives. Dialogue summary aims to generate a concise description of given dialogue content, which is normally formulated as a second-to-second generation problem. Dialogue completion eliminates the coreference and information ellipses in the latest utterance, which is also a generation task. Intent detection and slot filling are 2 traditional spoken language understanding tasks that aims to translation natural language to logical form. Intent detection is typically treated as a classification problem, and slot filling is usually formulated as a sequence labeling task. The dialogue state tracking task is to extract the user's constraints on the predefined dialogue domains and slots. In this paper, we try to model all the dialogue understanding tasks in the unified framework. There are 2 basic beliefs. The first is to transfer the task level knowledge among the different dialogue understanding tasks with different datasets. The second is to validate the effects between the dialogue understanding tasks, which is independent on the specific dialogue understanding model. We formulate all the DU tasks as a second generation task. However, the complexity of 5 DU tasks are diverse. For example, the output of intent detection is just a classification name, and that of the dialogue summary is content description. The various complexities causes the straightforward mix-up training process unstable, where the final model usually bias to more difficult tasks like dialogue summary and dialogue completion. In UniDU, there are 2 main challenges: how to constructing unified model for all data, and how to finding adaptive learning strategies for all the tasks. We first introduced a unified model for all the dialogue understanding datasets. For dialogue summary and dialogue completion, they are both traditional generation tasks. The input has 3 parts: task identification, dialogue content, and task description. The output have 2 parts: task identification and question answer. The original intent detection is a classification task. Under UniDU framework, this is also a generation task, where the classification name is directly generated. Under UniDU framework, the slot filling task consists of screenshot questions, where all the slots should be predicted by the unified model. Similar to the slot filling task, the dialogue state tracking task is formulated as sequential questions related to domain slots. The second main contribution of this paper is to find efficient training strategies for the unified DU model. There are 2 different multitask training methods: domain transfer multitasking learning and adaptive multitasking learning. TT means task transfer learning, where we just mix up 2 corpora from the same task. One is evaluation corpus, and the other is auxiliary corpus. Mix means the mixture learning that mixes all the available DU couple together. G2S and the CL are two curriculum learning methods from two perspectives. The training rules of G2S is from general task to domain-specific task. That of CL is according to the input complexity, like orderance, turn, and dialogue level. The adaptive multitask learning means that the losses from the different tasks are automatically distributed. There are two well-known adaptive multitask learning methods, HW and Grander. HW aims to slow down the learning scale that has the larger gradient. A Grander aims to slow down the learning scale that has the larger gradient and a faster convergence rate. In original HW methods, the distributed learning weights for each task are independent on the task itself. In this paper, we improved the weights as weight function of the task. The input feature of weight function is as shown in the box, including input features, output features, and data scale. It lists that the similar tasks have similar learning weights. There are 10 datasets in total used in our experiments. Each task has two couples. The experimental results show that the adaptive multitask learning methods can achieve better overall performance, especially on more complex tasks. Compared with the well-designed baseline models, our unified model can get competitive and even better performance. There are two kinds of ablation study to validate the effects of pre-trained language models and the influencing of dialogue understanding tasks. Compared with random initialized transformer-based model, the pre-trained model as backbone can obtain a voice performance gain. When we remove the dialogue completion task, the other four tasks have more performance decreases. We also test our unified model on unseen dialogue. We can see that our unified model still can output reasonable answers. This is all. Thank you.